The IT challenges in today's data centers are formidable. Technology investments need to address these challenges and simplify infrastructure, starting with a technology foundation that is flexible, efficient, and cost-effective. Introducing the Intel Xeon Processor E5-2600 product family, the heart of the optimized data center. Meet demanding requirements with unmatched performance. Reduce storage and networking bottlenecks that hold applications back. Improve energy efficiency and lower costs. Optimize your storage for virtualization and cloud computing, and increase security by protecting your data and infrastructure. Choose industry-leading tools to address your IT challenges. The Intel Xeon Processor E5-2600 product family, the heart of today's versatile data center and tomorrow's cloud.
High-performance computing, virtualization, consolidation, the cloud. These workloads increase performance demand on each server in your data center. The Intel Xeon Processor E5 family increases server performance by up to 80% to keep you ahead of these trends. Not only do these processors include more cores, larger cache, and greater memory bandwidth than previous generations, but they also feature new and enhanced innovations like Intel Turbo Boost Technology 2.0 and Intel Advanced Vector Extensions. Like its predecessor, Intel Turbo Boost Technology 2.0 delivers performance when your software needs it and improves energy efficiency when it doesn't. Here's how it works. It starts by looking for compute-intensive demands on the processor. When demand is high, Intel Turbo Boost Technology 2.0 determines whether the processor is operating below its thermal and electrical limits, and if there's headroom to spare, boosts the clock frequency of active cores to speed performance. The latest version of the technology enables the processor to go into turbo mode more often, for longer periods of time, and at higher clock frequencies to maximize overall compute performance. Another feature, Intel Advanced Vector Extensions, or Intel AVX, accelerates floating point operations by up to 2x. How does it increase floating point performance so dramatically? Whereas previous generation processors without Intel AVX processed floating point data 128 bits at a time, the new Intel AVX instructions utilize 256-bit wide SIMD registers, enabling software to process twice as many instructions per clock cycle. And that can significantly increase performance of applications running financial analytics, image, audio, and video processing, scientific simulations, and 3D modeling, rendering, and analysis. Intel Turbo Boost Technology 2.0 and Intel AVX are just two of the innovations that accelerate application performance on Intel Xeon Processor E5 family-based servers. Server processor performance has increased dramatically. This increase in compute horsepower has made I/O performance a primary bottleneck inside the data center. Recognizing this, Intel has designed several I/O performance enhancements within the Intel Xeon Processor E5 family to reduce I/O latency and improve data throughput. It all starts with Intel Integrated I/O. In previous generation system architectures, the I/O controller was a discrete chip called an I/O hub, separate from the processor. Intel Integrated I/O merges the I/O controller onto the processor, reducing latency by up to 30%, getting data to and from the processor faster than ever before. Another I/O performance improvement comes from adding support for PCI Express 3.0. This latest industry standard specification doubles the bandwidth per link to greatly boost I/O throughput. Another key I/O enhancement is delivered by the new Intel Data Direct I/O feature. In a traditional I/O transfer from the network interface, data must first be moved and stored in main memory. Only then is it transferred to cache for processing. When processing is complete, the data is sent back to cache and then once again moved to main memory before being transferred out to the network interface. Intel has intelligently re-architected the flow of I/O data in the processor. Intel's Data Direct I/O dedicates a portion of cache to I/O. This allows data to be transferred directly to cache from the network interface, bypassing main memory completely, further reducing I/O latency. The same is true on the reverse trip, when the processed data is transferred directly from cache to the network interface. This results in significantly improved I/O performance and reduced I/O latency, all while reducing system power because power-consuming main memory accesses are reduced substantially. Intel Ethernet products, with their high-performing stateless architecture, excel with Intel Data Direct I/O. Combined, these new I/O enhancement features improve and balance overall system performance and increase server efficiency for Intel Xeon Processor E5 family-based platforms. Server power limiting is quickly gaining momentum as a way to reach critical data center objectives, such as increasing rack density, optimizing throughput during power and thermal events at the system and data center levels, and facilitating power-based load balancing. Intel Node Manager delivers advanced instrumentation at the server level so you can optimally achieve these objectives. The technology allows data center management tools to communicate with Intel Xeon processor-based servers to precisely monitor and dynamically limit system-level power consumption based on the policies set by the IT administrator. This enables you to manage consumption across racks, aisles, and other groups of servers. To deploy Intel Node Manager, you need to specify these items as part of your server requirements. Here's how it works. The Data Center Manager sends commands via the Management Console to set a power limit for a server or group of servers in response to a power or thermal event. The Console Manager communicates power budget policies via the Baseboard Management Controller, or BMC, to Intel Node Manager, which is monitoring server power consumption in real time. The current power level is then compared to policy. If the system exceeds the policy limit, Intel Node Manager utilizes a closed-loop process to adjust processor and memory power to meet the target power level. This feedback loop ensures that server power consumption remains continuously controlled and predictable, and allows the server to perform as much work as possible while complying with the administrator's policy. With this improved control, you can include more systems per rack while operating at the most efficient temperature and power level for your infrastructure. Intel Node Manager is an industry-standard solution that can be delivered by any hardware manufacturer designing compliant Intel servers, enabling you to deploy and manage servers from multiple vendors in your data center environment with a single policy. Increase performance density, decrease ownership costs, and improve business continuity by ensuring your next servers include Intel Node Manager.